we're going to look at a few examples. So in this example, it asks us to rewrite in radical form and then evaluate where possible. So we're going to look at these expressions and we're going to rewrite them from power form into radical form and then try to evaluate it where possible. Remember, whenever you do have a rational exponent, that you want to look at the numerator as the growth and the denominator as the root. So that'll help you sort of distinguish where you're going to put each of those values once you have it in radical form. So if I were to rewrite the first one in radical form, the first thing I'm going to do is draw the radical symbol and write the base as the radicand. So k would be my base, or the radicand in this case. And so looking at the rational exponent that I have, the exponent of 1, or the numerator, which is 1, would go at the top here to represent a growth. And the denominator here, which is 2, would go in the index to represent a root. So this is sort of like the second root of k, or the square root of k. So I can also ignore the exponent of 1 here and write it as the second root of k this way, or I could just write it as the square root of k. Okay? All three of these mean the exact same thing. This is probably the easiest way to look at the expression in radical form. Can't evaluate this one because I don't know what the value of k is, so I would leave it the way it is. Okay, the second one, I'm going to look at two different ways of doing this question. And one way is to look at the root and then the exponent, the growth. And the other way is to look at the growth first and then look at the root after. Okay, so remember again, we have a rational exponent. The numerator represents the growth and the denominator represents the root. So one way to write this, and I'll start by writing 256 as my radicand part. The 4 is in the denominator, so it represents the root or the index, and the 3 is the exponent, so that represents my growth. Okay, so in the first case, what I'm looking at is the root first and then the growth. And the second way, I'm going to show you guys how to do it by looking at the growth first and then looking at the root. So let's finish up this way first. And what you'll notice is when I'm evaluating this, I need to find the fourth root of 256. And if I do that on my calculator, what that'll give me is an answer of 4. And so this just means 4 to the exponent 3, which is something I can easily evaluate. And since this represents a growth, I know this is 4 times itself 3 times. And so 4 times 4 times 4 is 64. Okay, so that wasn't so bad. I found the fourth root, and then I could easily find the growth right after, and that was 64. Now, the other way of doing the same problem is by writing my radical with the 256 as my radicand. But now, looking at the exponent part, I can look at the growth first, so apply an exponent of 3 here, and then look at the root after. Okay, so what this means is I need to evaluate what's underneath the radical sign first, and then find the fourth root. And so this is going to be really messy because 256 to the exponent 3 is probably going to be a really big number. And if I do that on my calculator, I get, okay, 16,777,216. Now I have to evaluate the fourth root of 16,777,216. So what you want to look for on your calculator is a button that looks like this. Okay, it shows a variable in the index and then a variable in the radicand. That's what's going to help you find the fourth root of 16,777,216. And if I evaluate this on my calculator, I get an answer of 64 as well. Now, personally, I prefer the first way I did it, and that's because these are numbers that I can work with and I can actually figure out in my head. This, on the other hand, I had to use my calculator to try to evaluate. So try to use a method that's a little bit easier to work with. And typically, if you find the root first and then apply the growth, it makes it a lot easier to work with. Okay? Once you find the root, you get a smaller number. Once you find a growth, you get a larger number. Okay? As opposed to if you find the growth, you get a really big number, and then you have to find the root, which will make it smaller, but it's still difficult to work with. Okay, the next one. Remember when you are looking at rational exponents, that these have to be positive integers only when you are looking at rewriting this in radical form. So because right now I have a negative exponent, the first thing I need to do is eliminate this negative exponent using my negative exponent rule, which means I need to rewrite the base to a positive exponent. So if I'm rewriting the base to a positive exponent, the reciprocal of 32 would be 1 over 32. And so now my exponent would be positive 1/5 on the 32. Okay, so that's a little bit nicer. So now that my rational exponent only has positive integers, I can rewrite this in radical form. So what I'm going to do is the numerator stays the way it is, and in the denominator I'm going to rewrite 32 as my radicand, and now I can look at my exponent that's here. The number at the top represents my growth, the number at the bottom represents the root. So that means the 5 is going to go in the index, and the exponent of 1 isn't really going to make a difference, so I'm going to leave it the way it is. So now that this is in radical form, what I need to do is evaluate the denominator. So the 1's happy the way it is. In the denominator, the 5th root of 32 means I'm trying to find some number that multiplies by itself 5 times to give me an answer of 32. So that number would be 2. And so if I simplify that, it gives me an answer of 1/2. Okay? Okay, some more examples. So again, we're going to rewrite in radical form and then evaluate where possible. And both of these are values that you can actually evaluate. And so I'm going to do the same thing here. First of all, notice that my exponent has a negative value. And when we are looking at rational exponents, your rational exponent needs to be positive before you can write it in radical form. So the first thing we need to do is we need to apply the negative exponent rule. So we will rewrite the base to a positive exponent. So that'll give me 1 over negative 27. And that's going to be to a positive exponent of 2/3. So remember to put brackets around your negative 27, just like it was here. The whole base is negative 27. And now your exponent's going to be 2 over 3. Okay, so now in this case, what I'm going to do is, now that both my numerator and denominator of my rational exponent are positive, I can rewrite this in radical form. So again, draw your radical symbol only in the denominator because that's the only place that your rational exponent's at. So this is going to be negative 27. And the numerator represents your growth, and the denominator represents your root. So the root is 3, so that's going to go in here. And the growth is 2, so that's going to go up top. Okay, the reason why I did the radical part first and then the root part first and then the growth part after is because this is something I can actually evaluate without a calculator, whereas if I did negative 27 to the exponent 2, I would probably need to use my calculator. So this just makes it a little bit easier to work with. So I can evaluate the third root of negative 27 or the cube root of negative 27. This just means some number multiplied by itself 3 times gives me an answer of negative 27, and that number I know is negative 3. So that gives me negative 3 inside the brackets. Then I still need to apply the growth of 2. Okay, or an exponent of 2. And so the numerator is still happy the way it is. Negative 3 to the exponent 2 is equal to 9. So I get 1 over 9. Okay, in these rational exponents, you're not allowed to write these as decimals. You will need to leave them in fraction form. So that's why it's important to make sure you write it in ways where it's easy to either calculate or easy to actually check your work. Okay, the last example that we have here is 9 to the exponent 3.5. Now this is weird because 3.5 is not actually a rational number the way it's written. So I'm going to rewrite 3.5 as 7 over 2. So this is the same as 9 to the exponent 7 over 2. In which case, now that both the numerator and denominator are integers, I can rewrite this in rational form. Sorry, in radical form. So 9 is going to be the base part, and the denominator is my root, the numerator is my growth. And so essentially I'm looking at the square root of 9 and then raised to the exponent 7. And the square root of 9 is equal to 3 raised to the exponent of 7. This is where I will need my calculator. So 3 to the exponent 7 is equal to 2,187. And that's it.